Okay, hello everyone. Welcome back to the channel Master the Codes, and today we are going to talk about bipartite graphs in the graph series. And this series is for all those preparing for placements, coding interviews, or who have just reached out to the graphs and want to gain more experience, right? So to keep the content growing and staying notified, please like, share, subscribe to the channel for more notifications and such related content. So let us get started with the bipartite graphs. In this particular video, we are going to talk about what are bipartite graphs, when they are used, how to create a bipartite graph, how to color a bipartite graph, and how to find whether a graph is a bipartite or not. So starting into it, first of all, we are going to talk about what is a bipartite graph, right? Let me first tell you it is a graph coloring with only two colors. If I am drawing a graph, let me draw a graph. If I draw a graph, let's say like this, right, and name them as 1, 2, 3, 4, 5, 6, and 7, I can only use two colors. I can only use two colors to color the graph, and that color can be either red or white, yellow or black, or any other. Rather, the color has to be 0 or 1 if you speak it mathematically, right? You cannot color give any other color to the graph. So if I just started, I can give this node as red color, then this node as white, this node as red, and these nodes are also as red. Also, the most important thing about bipartite graph, any two neighboring nodes, any two neighboring nodes or neighbors cannot have same color. They cannot have the same color. As you can see over here, this white, this node 5 and 6, one is given white and one is given red. If I change the color to, let's say, right, if I change the color to red over here, if I change this color to white, then this node is not at all bipartite, or this graph is not bipartite. So to keep it bipartite, you need to have all the neighbors of different color, right? Neighbors should be of different color. Neighbors should be of different color. This is the most primary and important condition for a bipartite graph, and keep that in mind, right? Now, if I draw a random graph, let's say I'm drawing this type of graph and naming the nodes as 1, 2, and 3, and let's say I started giving two colors. I choose the colors as red and white, right? R for red and W for white, and I'm giving it as red, right? Then I come to node 2 and I give this as white because 1 and 2 are neighbors and they cannot have the same color. Now, if I give this as red, then these two nodes have the same color, which is not correct. And if I give this as white, then these two nodes have the same color. So the graph will not be bipartite, because if I'm giving red, these two nodes are of same color and they are neighbors, and if I'm giving white, these two nodes are of same color and are neighbors. So first thing is how to identify whether a graph is a bipartite or not. Let me give you a bit of intuition and let's see if you can figure that out or not. If I draw a single node, right, if I'm drawing a single node, this is graph G1, and I'm drawing a single node, you can directly give it any color, either a red or a white, and it will be a bipartite graph. And if you give two nodes, you can give one as red, another one as white, and this graph G2 will be bipartite. And if you create three nodes, if you give this red, if you give this white, and you give this white, it will not be a bipartite, right? This node, this graph G3 will not be bipartite. And if I create a graph like this, red, white, red and white, and this will be a bipartite graph. So if you look at these intuitions, what I'm saying is, if a cycle exists, then it has to be an even length cycle, right? It has to be an even length cycle, not an odd length, an even length cycle. The graph G1 is a cycle in itself because you have only one node. The graph G2 is also cycle because you can go from node 1 to node 2 and from node 2 to node 1. This is a cycle as well. You can go from 1 to 3 and you can go as anywhere. Even this is also a cycle. So if you look at these, if in a graph you find a cycle and that cycle is of even length, then there is a chance of bipartite graph. Or a more better way of saying is, if you find any graph that contains a cycle, right, that contains a cycle of odd length, then it is not a bipartite graph. First thing, as you can see over here, a bipartite graph always contain an even length cycle. Now if I draw a graph like this, and from here as well I am drawing a graph like this. Now looking at this graph, I am giving the name of the nodes as well: 1 2 3 4 5 6 7 and 8, and I am assigning colors. Let's start from node 1 itself, red. I'm giving this one white, I'm giving these two as red, I'm giving these two as white, and this is red. And whether I give it this white or red, there will always be a mismatch because two neighbors will have the same color. So what do you think is better? Like, the question is, which thing is better, finding an odd length cycle or an even length? Actually, you don't need to do any of these. If you are checking a bipartite graph, you can run a DFS or a BFS traversal. These things you need to check if you are running a DFS traversal. And if you don't know what is DFS, please check out the fourth video in the tutorial, and there I have explained what is the DFS. And if you are running a BFS, you just need to run a BFS and use a coloring technique to color the nodes. I'll tell you what this means, the coloring, right? So that is how you, or rather these are the properties of bipartite graphs. Now we are coming to the coloring, right? The coloring of a bipartite graph. Now for that we need to use the color array. Now what do I mean by this color array is, I'm creating a graph. Let's create the same graph, right? Or a little bit simpler graph I'm creating, and name this as 1, 2, 3, 4, and 5. Right. Now, what do you mean by using a color array? I'm saying is create an array. Right. Create an array of n plus 1 size, where n is the number of vertices or the number of nodes in the graph. Now, why I am saying this n plus 1 is because in a graph, the numbering usually starts from 1, and in an array, the indexing starts from 0. 0, 1, 2, 3, 4, and 5. So even though you are not using this 0, but you still need to take it, so as to provide a direct correspondence or a direct key or value pairs or a direct matching to the every node in the graph with the index of an array. Now, if I'm giving this value as red, I can mark this as -1 or give it any value 2, 3, 4, 5, whatever suppose, but usually -1 and 1 are preferred. And you're giving this white, then you can mark 2 as 1, and if you're giving 3 and 4 as red, you can mark 3 and 4 as -1, and if you are giving 5 as white, you can mark 5 as 1. So that is how you use a color array. This is a color array to color a bipartite graph, right? This is one technique or other technique of coloring where you use an array and we rather form a BFS traversal on the graph, and whenever we encounter an uncolored node, we give it -1 or 1 depending on the color. Now, you could have given this color as 0 as well, but we never take it. Why? Because whenever we are creating an array, the array gets automatically filled with zeros. So even if you choose color, let's say 0 and 1, like 0 for red and 1 for white, when you're filling an array, the array will automatically get filled with all reds, which you do not want. So that is why we create an array, we do not want this, and fill it with the values of -1 or 1, where -1 represents the red color and 1 represents the white color. Now, coming to the algorithm, we create two arrays, one visited and one color array, perform the BFS traversal. Let's look at this example. I'll explain it to you. I'm creating the array 3, 4, and 5. Then what I need to do, I need to create a visited array. This is my visited array, and I'm creating this as a color array, right? 3, 4, 5, and 1, 2, 3, 4, 5, and I'm giving them the indexing as well. Now, how is this thing work? Let's say I'm also creating a Boolean variable. If you don't know what is Boolean variable stores values of true or false. I'm giving a Boolean variable where, let's say, color, and I'm giving it as true, where true represents red and false represents white. Now, Let us start with the algorithm. But before that, we need to create the adjacency list as well, right? So let's create the adjacency list, which is 1 is connected to 2 and 5, 2 is connected to 3, 4 and 1, 3 is connected to 2, 4 is connected to 5 and 2, and 5 is connected to 1 and 4. And this is what is our adjacency list. And if you don't know what is an adjacency list, please check out my first video, and there I have mentioned what all it is. Now, starting with the algorithm. Currently our color is red, that is true. Okay, we are using BFS. Remember, we are using the BFS algorithm. And if you don't know what is BFS algorithm, check out my previous videos. I have mentioned it over there as well. Now I'm starting with node 1. I'm adding node 1 into the queue, and I'm marking node 1 as visited, that is true, and giving the color as red, that is 1. Okay, then I'm adding all the neighbors. I'm adding the neighbors of 1, that are 2 and 5. And when I'm adding the neighbors of 2 and 5, I will reverse this color. Like if it is true, I will change it to false, and the color will become white. And now the color has changed to false. Now I will go with 2, and I will add all the unvisited neighbors of 2. Now what are the unvisited neighbors of 2? 2 has neighbors 3, 4 and 1, out of which 1 is already visited. So I will add 3 and 4, and I will mark 2 as visited, and using this color white I will give 2 as -1. Now I am coming at 5. Right, up till this point I have to give the same color. Up till this point I have to give the same color. So now 5 now what are the unvisited neighbors of 5? They are 1 and 4. 1 is already visited and 4 is already added into the queue, so we do not need to add it again, or even if we add, it won't matter. Right, now and 5 will be given the same color as white, that is -1, and will be marked as true. And when we are doing this, we will check if, when we are giving this color, we will check if there's any neighbor with different colors, or rather with same color. Now you can see 5 has neighbors 1 and 4, right? And the color of 1 is 1, and the color of 4 is currently 0, and the 5 has color itself -1, so it is not matching with any of them. Thus our coloring is good for now. Now we are come to node 3. Node 3 has only 2 as the neighbor, and that is visited. We will not add 2 into the queue, but this white color will get changed to true and will become red, and then this 3 will be given as 1. And when I am giving this as 1, I will check its neighbors. What are the color of its neighbors? As you can see, the color of neighbor 2 is -1, so it is all good. I don't have to worry about it. Then I will remove 3, like I have removed 2, remove 5, I'll remove 3, and 4 will come into the queue, right? I'll mark 3 as visited, and when this 4, I'll check its neighbors 2 and 5. 2 and 5 both have minus 1 and minus 1, and I'll give 4 as 1, and both of them are same or rather different, then our coloring is correct. And then the last 4, I'll simply remove it because it's a duplicate and the cube will become empty. And when this cube will become empty, my BFS algorithm will end and my color is generated. Now if you want to see what is the color of each and every node, like if I want to get the color of node 3, what I can do, I can simply write color of 3, and then this 3 will be give me the output as 1, and we know 1 is for red, and if I'm getting minus 1, that is for white. So that is how a coloring algorithm takes place in the code. Now we will go into the code as well about learning what this coloring algorithm does. Before that, please like, share and subscribe to the channel and hit the bell icon for more notifications. change the color. And then the neighbor of 1 is 2 and 5, that means 2 and 5 will be added into the key. And when I have given color to both of these nodes, 2 and 5, then only I will change or reverse the color. And then after all this algorithm is over, I'll break DSS and return true. That means all the nodes are colored using exactly two colors where no two neighbors have same color, and hence it is a bipartite graph. As you can see over here, this is a bipartite graph, and if I run the code and copy this input test case, I will get the output as true. And if you look at over here, I copy this particular test case and run it. I'll get the output as false. That means it's not a bipartite graph, because you can see it contains a cycle that has odd number of nodes, right? It contains a cycle that has odd number of nodes, and that is how you check whether a graph given graph is bipartite or not. I'll share this code with you in the GitHub and link it down in the description below. Please do not forget to like, share, subscribe to this channel, and hit the bell icon for more notifications. Also, I will be providing the notes mentioned as well in the link in the description down below. So please don't forget to like, share, subscribe to this channel. Until then, bye bye and have a great day.